This is Algebra 1, Factoring and Simplifying Rational Expressions. So we've spent some time on this, but I think we could use another day to review it. So let's go back. We're going to start with factoring, because you can't simplify a rational expression until you factor it. So we're going to start by factoring this trinomial. So we're looking for the greatest common factor of 8, 24, and 12. And then we're going to look for the most x's we can take. If you can look at this and say, hey, I can see that 4 is the GCF, that's great. Go ahead and do it. If you can't, then there's no problem. You can just go ahead and factor. So we're going to do a prime factorization of 8. So we have 8. We could break that down in 2 times 4 and 2 times 2. So we have a 2, a 2, a 2. One of them has to be negative. And we have 7 x's, 1, 2, 3, 4, 5, 6, 7. 24, if we break that down, 2 times 12, 2 times 6, 2 times 3. So we have 2 times 2 times 2 times 3, and we have 6 x's there, 1, 2, 3, 4, 5, 6. And last one is 12, 2 times 6, 2 times 3. So we have 2 times 2 times 3, and that one has 5 x's. 1, 2, 3, 4, 5. All right, so for the greatest common factor, we're listing things they have in common. It looks like they all have a 2. It looks like they all have a second 2, so we're allowed to use that. These two have a 3, these two have a 2, so we can't use that. And it looks like they all have at least 5 x's. So we're going to take 5 x's out. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So our GCF is going to be 2 times 2 times x to the 5th, or 4x to the 5th. Now what's left over is what's inside. We have a negative and a 2. So we're going to put a negative 2 back in there. And this one had 7 x's. We took out 5, so it looks like we have 2 x's left over. For the 24, we have a 2 and a 3 left over, so we're going to multiply those back together. That's going to give us a 6. And it looks like we have 1 x left over there. And for the 12x to the 5th, it looks like we have a 3 left over and no x's. Okay, and that's all we can do to factor that one. Let's try the next one. 2, 6, and 108. I think you could probably look at that and say, it looks like 2 is going to go into all of those evenly. Just need to make myself some room here. Okay, so I'm going to factor out a 2. This one has 2 n's, this has 1 n, this has no n. So it doesn't look like we're allowed to take an n out. I'm going to take a 2 out. That's going to leave me with n squared. I'm going to take 2 out of the 6. So 6 divided by 2 is going to give me 3, and the n stays in. Negative 108 divided by 2 gives me negative 54. And before you say, hey, I'm done, look at what you have left over. See if we can factor again. It looks like we're going to be able to backwards FOIL this one. So we're looking for 2 numbers. When you multiply them together, you get negative 54. When you combine like terms, you get a positive 3. So we know one of them is going to have to be a plus and one of them is going to have to be a minus in order to multiply 2 terms and get a negative. So I start listing my factors. 1 times 54, 2 times 27, 3 goes in there. How many times? 54. Divided by 3, how about 3 times 18? 4 doesn't go into evenly, 5 doesn't work, 6. 54 divided by 6 gives us 9. 6 times 9. 7 doesn't go into it evenly, and we're back to the 9. So those look like our choices. Now we're going to look which one can we subtract and get a difference of 3? So it looks like the one that's going to work for us is 6 times 9. And when we combine like terms, we want the 6 to be positive. Whoops. We want the 3 to be positive. So that means we're going to make the 9 the positive one and the 6 the minus one. Now we are done. Okay, so you first have to factor out the GCF, and then you have to factor it into two binomials. Let's try one more of those. Here we go. We're looking for the GCF of 5, 10, and 20. Again, maybe you could look at that and say it's 5. If not, start doing your factor trees and see what they have in common. But I'm pretty sure I could take a 5 out of all of those. This one doesn't have an n, so we can't take any n's out. So I take 5 divided by 5, that gives me 1. We don't really need that 1, so I'm just going to say n squared. 10 divided by 5 gives me 2n, and 20 divided by 5 gives me 4. So again, before we finish up, we say, can we factor this any further? Are there any two numbers that when we multiply them we get 4, when we add them we get 2? So it could be 4 times 1, or 1 times 4, and 2 times 2. And the only way we can get a positive is if they're both the same. So the only way we can end up with a difference of 2 is if one of them's a negative. So it doesn't look like we're going to be able to do this one. There's no choices. That means we are done here. All right, let's try a rational expression now. Now we're going to take what we just did, but we're going to put it into a fraction. And again, we're looking for a greatest common factor between 16 and 28. If you see it, great. Go ahead and use it. If not, let's go ahead and break this down. So it looks like we have 4 2's and 2 p's. And let's go ahead and do the 28. 2 times 14, 2 times 7, so we have a 2, a 7, and this one has 1 p. So what do they have in common? It looks like they both have 2 2's, so we're going to take 2 2's out, or 4 out, and they have at least 1 p, so we're going to take 1 p out. And then on this one, we're left with 2 times 2 times p, 2 times 2 times p, or why don't we make that 4p, make it a little bit prettier. So if we take 4p times 4p, we're back to the 16p squared, and we took a 4p out of here. We were left with a 7. We're going to cancel out those 4p's. And we're left with 4p over 7. Here we go again. 45 and 10a minus 10. 45 we can break down. 45 is 5 times 9, which is 3 times 3. So if you want to think of that as 5 times 3 times 3. This bottom one, it looks like we can factor a 10 out of that. So we're going to factor a 10 out. This one doesn't have an a, so we can't take any a's out. When I take 10a divided by 10, I'm left with 1a, or just a. When I take 10 divided by 10, I'm left with 1. So I'm just going to put a 1 there. And on the top, we said we have 5 times 3 times 3. Let's go ahead and break that 10 down to 5 times 2 so we can see it a little bit better. Looks like we have 5's in common. That's about the only thing we can simplify. So I'm going to keep my 3 times 3, or 9. On the bottom, I have 2 times the quantity a minus 1, and we are done. All right, last one. Oops. Let's make some room to work here. Okay. So I have x minus 4. Nothing I can do with that. There's no way I can simplify that. In the denominator, I have 3x squared and a 12x. The greatest common factor of 3 and 12 is going to be 3, so I'm going to factor out a 3. This one has 2 x's, this has 1 x, so it looks like we're allowed to take an x out. So if I take 3 divided by 3, I'm left with 1. X squared divided by x, I'm left with 1x, so I don't need that 1, but I can put it there if I want. If I take 12 divided by 3, I get 4. X divided by x is 1, so I don't need that anymore. And you can see what we can simplify right here. Boom, boom. We're allowed to cancel those out. On the top, we're just left with 1. We can't just get rid of that. We can't make our denominator the numerator. So on the top, I'm just putting a 1 to hold the spot, and the bottom, I'm putting a 3x. I hope this helps. This time, I made it into a keystone review of the rationalizing, or simplifying rational expressions and factoring. If you have any questions, let me know. Thank you.